have in these more recent systems. And what I hope is that the Curlin system will provide a wrapper for the facilities that we've got in Tickle, so that more people will find them easier to use. And we hope that we'll not only be able to get more applications developed and homed on the Curlin server, but also that we'll get more users coming in to use Tickle, because I think the facilities that we've got are fantastic. I constantly have to ask myself, why don't more people use them? Why is Tickle not a bit more fashionable? That's a question I'm sure that we all ask ourselves. So I'll stop there. Any questions?
The 32K pixel limit you reported, that's
yes.
on Windows, or are you seeing it on other platforms also?
I'm seeing it on X11.
That bug was supposed to be closed back in 2002. Please report it.
Oh, sure, yes.
Regarding the safe interpreter, have you done that? First of all, is it easy to just substitute a regular non-safe interpreter so you can get the sockets and all the stuff if you wanted to do that type of work? Or is it something that's designed inherently around the safe interpreter right now?
At the moment, it's inherently around the safe interpreter. I guess it wouldn't be hard to switch out the safe interpreter for an unsafe one. What's a lot more difficult is to get to grips with the facilities that are available in security policies and adapt them to the circumstances that we want.
When HTTP version you're supporting, 1.1?
1.1, yes, and that's another thing that's been really handy, that the HTTP package that's in the core is now working with 1.1, so we use that exclusively on the client side.
Are you expecting that people will usually be talking to your server, or do you expect customers to be able to run their own servers?
Well, the clients are quite general, so they can load ticklets and data from anywhere as long as they have as long as they send the right MIME type. Our server makes it easy to upload data to go the other way, and yes, I think ultimately, if other people have their own servers, that would only add to the system.
Have you looked at Richard's Fossil source configuration management tool?
No, I haven't yet. No,
because I've been playing with that the last couple of days. It's very cute, but one of the neat things is it's a single file
yes.
program. You can start it up anywhere, have it manage a repository that's an SQL-like database,
yes.
and you've got a full source configuration management server sitting there, running wherever you want it with almost
yes.
no trouble at all. It's the whole time you were talking about your clients, I was thinking, that would make a nifty back end.
Yes, we for the back end haven't said much about that, but it's really more wiki style at the moment. In that, if we have say 1,000 files up on the server, and one of them is a little applet that someone wants to modify, then the usual mode of operation will be that they'll check out that file, or they'll simply open it in the editor, do their editing, and then save it. And when it's saved, it doesn't go back to the public repository, it goes to their own private workspace. And when they've got it to a state that they're satisfied with, then they can commit it to the public repository.
You ought to take a look at Fossil.
But it works one file at a time.
Yeah, you ought to take, not that Fossil is what you would use as your back end. I'm just thinking sort of the way it does things.
Yes.
And the fact that it is so lightweight.
Yes.
It would mean, gosh, I'd like to try using their stuff, and I'd like to have my own server. Well, it makes it really easy to get started. You can just throw it into your home directory and give it a try. And if you don't like it, you can blow it away easily, or work out how to make it.
No one's ever done that, Will.
What's not to like, Will?
Yeah. I haven't yet. So.
Can you expand a little bit more about the sort of ecological niche of organizations or users that you're targeting?
Well, at this stage, we're really going for something like the wiki community, but it's not a wiki. The resources that you'll download will be applications that are intended to run straight away. So it's aimed at that sort of community, but for writing applications rather than writing, say, something like Wikipedia. And because users have their own directories as well as the public directory that's world writable, it's not a disaster if someone overwrites your contributions, because as we've learned in some of the talks and tutorials, everyone has their own ideas about what GUIs should look like, and so people can have their own copy as well as perhaps the very fast-moving one that's in the wiki style directory.
Thank you, Keith.
This all went perfectly when we tested it.
Well, it's not gonna work, you're not using my notebook.
All right.
Okay, next up are the power team with Steve, Mike, and Cindy. We're going to talk about two key Stargis technologies.
Full stooges.
Okay, I've talked about Stargis before. In fact, it was 4 years ago here. But for those of you who haven't heard of the project, I'll give a little background. The Stargis project, the goal is to create an environment that makes it easy for domain specialists, non-programmers, to create secure, reliable, and scalable applications without being tied to specific hardware platforms and without having to become a software development expert in order to create their applications. Or, as Frank mentioned yesterday, to allow non-programmers to create programs without programming. The approach that we're taking is to create abstractions of various aspects of the application development cycle, including data storage, user interfaces, security, and communications. The typical approach is to start with interfaces and then work from the outside in. We're taking this from a different viewpoint and starting with security and storage and communications and working from the inside out. In terms of background, the name Stargis comes from Starkits and Argus. If you know your Greek mythology, the Argus was a many-eyed, vigilant watcher, and that sort of had some similarity with what we were looking at, especially on the security side. We did a workshop that was held in January of 2005 that led to some work. We presented some initial results and an overall project plan in Portland in 2005. Several projects sponsored under this umbrella include some things that people will recognize: CryptKit, Tequila 2, Blurk, TK-HTML3, Political, and Critical 2. These things were sponsored by EOS Technologies. Within the last year, I created a non-for-profit foundation that is now sort of taking over the sponsorship of the Stargis project. It's called the Buona Corsi Foundation. I can tell you about the name later, but that's the name of the foundation. The NatLab project that we presented about yesterday, we were looking at where to take it next, and the next phase of the NetLab project is to start building a online community environment for having collaboration surrounding the building of that knowledge base. And so we thought, hey, this would be a great test bed for building out the Stargis platform. And so our first application domain is this NetLab system and where it's going, including the shared annotation environment, looking at things like unified user management across the cloud as well as unified logging across the cloud. I will now hand off to Steve Huntley to take things from there.
I'm Steve Huntley, and the intent of this part of the talk is basically to describe the problem space that became apparent to us as we were working on a NatLab. So it became clear to us that in order to take things to the next level and scale in terms of the number of users who were using the NatLab and the amount of resources we want to apply to various NatLab tasks, we're running into issues that have been part of the question marks of network computing since the beginning. Things like security, authentication, collaboration, logging in clusters, things like that, and that dovetailed with the groundwork we had been laying with Stargis. And as Amazon has been introducing its cloud computing products under the AWS, Amazon Web Services label, it became clear to us that we could make use of cloud computing resources to address those issues. I don't know how many people here have been using Amazon Web Services or cloud computing services in general. 1, 2, okay, not too many. We think it's going to play a significant role in the future. We found it fairly easy to use, so we're pretty enthusiastic about it. This is a handy quote from Wikipedia describing in general what cloud computing is. It's basically renting hardware and software services from a company on a pay-per-use basis, so that as an alternative to buying large amounts of your own hardware, and which you may only use fully for brief periods of time, and thus you can scale your budget better to address your needs as they arise. So we want to use Stargis in the cloud for the obvious reasons brought by cloud computing. Clearly, the cloud computing resources available have been designed to address existing challenges such as installing and administering databases, reliability, performance, scalability. It started to become obvious to us that it might be possible to use cloud resources in new ways to address long-standing problems that have resisted acceptable solutions. And so it does come with some drawbacks. For example, what maybe used to be a desktop API becomes a networked API, which raises problems of authentication and security and additional complexity of the architecture. And one of the goals of the Stargis project is to hide that complexity and present instead the simplicity we've come to expect with TCL applications. So we've isolated 2 basic problem spaces right now that we're hoping to address and giving them some labels, better ideas. We were thinking of for security authentication. We were looking at OpenID for that sort of thing, but then we were thinking, no, we need something better. So that is sort of a provisional name. Mockingbird is a evolution of the Tequila shared storage and collaboration engine that already exists. So this is a little cheat sheet of the existing Amazon Cloud Services don't know how many of them you've heard of or been interested in. We are likely to start dropping into using pure acronyms, so take a quick look at this so you know what we're talking about. The Elastic Compute Cloud is the virtual server service where you can spin up virtual services on the servers on demand, various gradations of power, make use of them for short-term needs, bursts of computing resources required, and then you kill them, you charge on a permanent basis. SimpleDB is a very simple database with limited querying abilities, but highly persistent and reliable. Simple Storage Service is like a large, very reliable web server that serves static files, static information on a highly reliable basis. And Simple Queue Service is a message queuing system, also guaranteed to be highly reliable. Theoretically will not lose your messages. The others we're not using as much use of. You may have heard of them. So, like I said, we were looking at OpenID. There are significant issues with that. We said we needed something better, and that was sort of the limit of our inspiration in naming. But basically, when you sign up for Amazon, you get basically a public and private cryptographic key. Once you have that, you sign your requests and send them off on their web services API, and they execute the key signing checks out. Then they have a proper copy of your private key. If the sign checks out with their copy of the private key, then they execute the web service and charge you for it. So if you're talking about collaboration with large numbers of people, you have two options. You can either ask everybody involved to get their own web services account, which is a barrier to entry, or you can give everyone else your key, which is an invitation for them to spend your money, which is not, in an unlimited fashion. So we need to find a way to address that. What we want to do is be able to give limited access to the Amazon Web Services based on identity and what each individual qualifies for. So what we want is a policy server of the sort that we've described in the past under the name Political, which is a policy applying application which we extracted from the Ticklet browser plugin. It's a way of defining policies in a domain-specific language, and then you authenticate. It's designed to limit the access of the browser plugin to the local platform. We're sort of turning that around and applying the idea of a policy server, which will authenticate users and then grant them access to services on a platform. But Political doesn't really have a sophisticated authentication function, so that's something we're trying to build into it. So OpenID, I don't know how many people are familiar with it, is something that is catching on as a means of using the same ID credentials to log into a broad variety of web servers so that you don't have to give a username and password to every web server that you want to have access to. It has been criticized for certain security vulnerabilities, and it's complex, and there are some difficulties involved with implementing it. We thought we could do a better job ourselves. There's a lot of history behind RSA cryptographic key pairs. SSH uses it. Amazon uses it itself. It's a pretty good model for for authentication. You have a public key which anybody can access, and a private key which you keep yourself. You can sign or encrypt messages with your private key, and the public key can be used to authenticate or decrypt. In the past, a lot of people have tried to there's been a lot of boosterism of using cryptographic key pairs. There have been barriers to adaptation, for example, management of your keys. So there has been such a thing as key servers in order to try and make public keys available to make the whole scheme more relevant and useful. They haven't really caught on. So our thinking right now is to basically use the Amazon Simple Storage Service as a simple key server where people can store their keys in a highly available server. And like OpenID, your identification would map to a URL the URL would contain a public key which anyone could access and thus verify your identity if you've signed or encrypted a message with a private key. So we're basically, with OpenID, for example, you need a somewhat smart client, a smart login server, and a separate smart identity server. And we're trying to at least remove one level of complexity by eliminating a smart identity server and replacing it with a dumb key storage system. So that would mean we will initially be developing smart clients in TCL, which would be generating key pairs and storing them on the web server and doing the signing. And then you could simply sign a request, send it to a policy server. The policy server could simply check to see that you were the owner of the key set by verifying against the public key. And so we're hoping to be able to scale authentication services using that method. And Steve's going to talk about the second part, Mockingbird, the shared storage component.
Thanks, Steve. Steve has TCL'd your left brain. I'm going to tickle your right brain. We've been through an exercise. Yeah? That's good. All right. Let's see what happens. How many of you are familiar with Tequila One? A few. How many of you actually used it?
For something real or just play?
Just played. It was a tool built by Jean-Claude Whippler in around about 2000. It implements shared persistent arrays using traces and sockets to give the illusion of sharing with multiple hosts. And it's got a really simple development model. Basically what happens, in a client you attach an array. When you write to the client, the write trace fires. When you write to the array, the write trace fires, passes it off to a server that then sprays it out to the other clients, and they apply the change to theirs. The code's nice and simple. This is real code. Tequila open, the server and the port. Tequila attach an array name, set a variable, and if you read it straight back, it's been set. And then all the other hosts will see the same thing. Positives, it's effective. It was used in commercial and open source applications quite successfully. And it's very productive. You can take a single user application that uses global arrays and you can make it network aware. But there are issues. It's not secure. It uses sockets with no security on top of them. It doesn't scale. It's nearly impossible to debug. That's another topic. I meant to ask Colin about debugging CoRows.
Right, they've got a bit of stake in them. You have to...
That's enough. And the data model of it'll be very similar to this I mentioned. The data model is rather simplistic, purely arrays. So back in 2005, Tequila 2 project started. It was a complete ground-up rewrite of Tequila, and done by Jean-Claude Whippler, and leaning on the experience of Mark Roseman, the group kit author. And Jean-Claude presented it in the Euroticial 2005 conference, and I encourage you to get a hold of that paper. You can find it via the wiki. Lots of things changed. There were pools which had collections of data in them which were similar to tables. It had potentially a generalized RPC mechanism of communication instead of a snailed-up socket, and it also had a generalized notifier mechanism. And this is how it worked. You wrote in the client, you changed the value. That value didn't change in the client immediately, because now instead of writing to an array, you used a method call and an object. That was propagated down to the server and out to the other clients, as well as back to the original client, at which point an event or a notifier triggered. And the code was a more object-oriented API. We create an RPC, we create a pool, my pool, so a pool of collections. We set a value in a particular collection, and then you would think you could just print the thing out. Unfortunately, if you did that, you may or may not get back a new value. Because as I mentioned, it comes down here, goes back out, at which point it's visible. So the actual code looks much like this. You have to think asynchronously. First, for attachment, you have to set a notifier for the attachment, and then wait till it completes. And same with setting a value, you have to bind, it's going to set the global change value and your V weight on that thing. And at this point, you can look at the value. I've built a bunch of applications using this, and I just cannot think async. I mean, it tricks up experienced programmers. It's a problem. And Tequila 2 was an intermediate step to the scalability and other benefits. We didn't actually achieve those. So just a quick redux on Tequila. Tequila 1, simple, familiar, useful even, but it's not scalable. There's no reliability built in. Tequila 2, it's a foundation for those things, but the development model was... Anyone use Tequila 2? Yeah, I remember that XDA. So Cliff got tripped up by it. We had some interesting, anyway. So we decided to revisit the whole thing, and we came up with this idea of Mockingbird, or Tequila Mockingbird as... Anyway. I promised Steve Redler I would only say it once.
Nevermore.
Nevermore. We want scalability. Yeah. Oh, there was a whole afternoon of name anyway. It was a real slammer. So we have the simplicity, or we want the simplicity. Now this is a design exercise. You're not going to ask me for code. We want the simplicity of the Tequila 1 API, but now we have cloud computing, so we can do a whole lot more in terms of reliability and scalability. All right. We had some subsequent goals, which were really to take it more in the direction Tequila 3, and this might be Tequila 3. And we also, yeah, all right. So when we start to look at this, we've got to have a look, first of all, at what features are available in the cloud that we can use, and then we start to think about the API. We don't really care about the communications model, because that's sort of handled for us by the cloud computing. So the first feature we want to use in the cloud is this thing called Amazon SimpleDB that Steve mentioned. It's basically a giant distributed hash table. Now, a few of us have heard of tuple spaces. In the paper, I list the various tuple space implementations in the Tickle world. If you look at Facebook, if you look at Twitter, don't look at Twitter, look at Facebook or some of these social networking applications, they don't have SQL databases behind them. They have basically tuple spaces where they want to associate a key with some values. And they can get performance and scalability in a cloud environment because of that. Steve mentioned those other things. So the Mockingbird API would be really simple. A connection, like Tequila 1. We would have an authenticate command. Obviously, that's to authenticate the user. We don't need that. But otherwise, it's basically the same as Tequila 1. Maybe a detach. We're not sure if you need to detach, but keep the array connected. So when the user calls to connect, what happens? Passes a URL, which is the ID. Back comes some code to be executed to implement the authenticate command. Now, by doing it that way, it means we can adjust the authenticate command over time. You've seen Facebook, the way that works. If you want to use Facebook Connect to authenticate your application, just stick a little construct in there and they fill in some code at runtime. It also means we can pass back TK code. We could pass code that you could then use to authenticate without TK. You could prompt yourself. And we can make changes centrally. As well as that is a one-time key used for authenticating and encrypting communication during that session. It will also pass back the political rules. Even though in our model the data goes to the server, and unless it passes the political rules, the data won't be sprayed out, it would be nice at least to have those rules available in the client, so you might not even send it to the server and pop up a message or whatever. Otherwise, it's Tequila 1. But we can go beyond Tequila 1. We can have a local cache. That will give us faster startup time on big arrays. It could be SQLite, it could be anything behind the scenes. We don't really care, but it would be used to fill the local copy at startup time. We could support sparse arrays. Now, I haven't figured out why. At some point, I think I had this discussion with Donald. It must have been Tickle 8.4 where the trace variable command came in, because this would allow us to have an array which is filled on demand. A retrace that fires when you read something that hasn't been filled in. It waits, the data is fetched from the cloud, and then your read continues. There's an example in the paper where you can actually try it out, a script. it would allow a lazy attachment. This would be particularly useful for really big arrays. And you could do some really fun things, like you could have a little process that fires up every 10 seconds or whatever, or is run whenever you try and set a value, and it could start acting like a pseudo memory management system, limiting the amount you actually have in memory at any one time by throwing out least recently used parts of your array. And of course they'll be filled if you read them again. And I think perhaps there's a role for coroutines. I don't know, I'm trying to get my head around coroutines still. And the third thing is the simple array data structuring is enough. So we'll still have to have Tequila 2 style collections. So we can basically have a one-to-one with a more table-like structure in the background. The other thing too is the dict with command. If you haven't used that, it's, who remembers the Pascal structure with command? Gerald, oh, there's a few here. It really does make it, it's very nice for abstracting your code. And the other thing we're going to throw in there is the lock code that came out of KitView, which I presented back in 2000. So it's a distributed layered locking interface, so you could actually say, let's say we had a spreadsheet fronting this thing, you could lock a particular cell, somebody else wants to edit that column, they can't proceed with their edit until that cell's freed, and they can wait for it and so forth. And much later we might go for the more generalized stuff. Okay, so that's what the API would look like. So we start to think about how would we implement this on the cloud. Now the first thing you would want to do is to basically, well, first thing you might want to do is basically say, let's get a virtual server and we'll run Tequila in there, basically, Tequila 1. But there's a problem because every virtual server is going to have a database, therefore we can't use the automatic facilities to run up more servers because each of these servers have state. There's another problem, these are nailed up socket connections. So really all we're going to have is a virtual server. We don't need the cloud for that. So then we say, okay, let's pull the data out into SDB, and then we can nail up additional servers, and they can get their data from SDB, and that's really good. We can use the Elastic Cloud, Elastic load balancing to fire them up. But you've still got nailed up servers over here, nailed up sockets, I should say. So